Says recording. Okay, what we're going to do is start solving equations today. Up until now, we've done a lot of basic foundational stuff. Now we're going to kind of put it together, and we're going to do the actual foundation of algebra. You have to know how to solve equations. And believe it or not, if this is new information to you, it will become old hat to you really fast. Okay? So I start at the beginning where I explained to you that an equation is going to have two sides, okay? Two sides that are equal. This is the definition of an equation. It just has an equal sign, which means that the two sides are equal. Now, when I think about an equation, I think about, you know, on the front of a courthouse or the front of a lawyer's office, have you seen the blindfolded lady that's holding up the scales that are perfectly balanced? Okay, if you haven't noticed, you might notice she's blindfolded, and what it means is blind justice. It means it's going to be justice no matter who you are. Everything's going to be equal and balanced. Okay, so I think of that when I look at an equation because both sides of the equation have to be balanced. Okay, now what is cool about equations and solving equations in algebra is that really and truly you have a lot of freedom to do what you want to an equation. You can do pretty much anything you want to do, but the one rule, and you'll find this all the way through, we've found it with fractions already, that if you do one thing to your math problem, you have to do another thing to counteract it so that it will balance. Okay? And so that's the whole concept behind what we're going to do. Okay? We think of this as the scales, they have to balance, and here's where she holds it up, you know, and here's the two sides that are balanced. Now, if you went into the grocery store and you saw a scale like this, and you put a banana in here, okay, what's going to happen to that? It's definitely out of balance, isn't it? How are you going to get it back into balance?
Take the banana out.
Okay, she said 2 or 3 bananas over here. What she's trying to get at is you've got to put enough stuff over here so it balances again, right? Right. What if you could find another banana that was exactly the same shape, exactly the same weight, and you put it here? Of course, it's going to balance out perfectly, right? Okay, that's the whole idea behind equations. If we decide to do a banana to one side, we've got to do exactly the same thing to the other side to make it balance out. Okay, this is how it works. Now, these are the steps that I encourage people to do. Here's your first example. Okay, here's an equation. Now, when I say that we're going to solve the equation, that means I need to find out what value would be put in here to make this equation true. Now, of course, I start out with something very simple that you can see the answer already, right? But we're going to show you the steps in order to find out what this x is equal to. Now, before we get started, an x is an unknown. We call it a variable. Variable, A-R-I-A-B-L-E. Variable means that its value can vary in different problems. I can have an x in this problem that we see is going to be 6, but I can use an x in another problem and maybe it's -12. You know, a letter just stands in the place of some value, okay? And we're going to try to find out what that value is. Now, again, I said you can figure out that this is 6 right away, But I'm going to show you the steps that you need to follow always to solve an equation, because they won't always be so short and simple. And there's a lot of them you will not be able to figure out, just by looking at them. Okay, so the first thing that I found out that is very helpful is that we show our brains the division point. So we use a line down through the equal sign. I like the dotted line. Lots of people like a straight line. But divide these into the two sides so you can see this side has to equal this side. Y'all see? And the other thing in teaching for so long, I found out that if you solve a variable, then we can focus on this. This is what we want to find the value of. Okay? Now, here are the steps. Oh, the one thing that we need to talk about are opposite operations. Not hard again. If you have add, what would be the opposite operation for that? Subtract, of course. And if we have multiply, okay, we're going to divide. And right now, we'll just deal with these. Okay, we're going to use square root and squares later, and that's not hard, but let's just do one thing at a time, okay? Now, if you have something that is added and then something that is subtracted, and it's the same value, let's say 8 and 8. If you have a positive of that value and a negative of that value, you're going to have 0, which will cancel that piece out. Okay? Everybody okay with that?
Yes, I still remember this.
You remember this? Okay. So the whole idea of solving an equation is we want to do the steps necessary to get down here where we have x all by itself equals some kind of value. Okay? When we get to this place where x is by itself on one side, then we know we're finished. Okay, so if this is where we want to get to, and this is what we have right now, we need to focus on the side that has the x on it, okay? Now, we want the x to be by itself, but it's not by itself right now. And so we have to get rid of the extra stuff, you see? Now, if we have a plus 5, how will we get rid of a plus 5? A minus 5, okay? Or a negative 5, doesn't matter. If we have a plus 5 and a minus 5, that's going to give us 0, and that'll be great because x plus 0 is just x. Okay, but remember that negative 5 is our banana. And now that equation's out of balance and it has to be in balance. How do we get it back in balance?
The exact same.
Yes, we have to do the exact same thing to the other side. Okay, so we have to put a minus 5 over here because it has to stay balanced. Now, I found out that dividing or separating your steps helps a lot too. So as soon as you put your bananas on the line, then draw a line. Now we're going to go straight down. You do not have to bring your 0 down. I like to just 0 out right here. Say that plus 5 and minus 5 is 0. So all I have left now on this side, I'm going to add straight down, So I have x equals 11 minus 5 is 6. Now later on, we're going to have more than one step. But if we look at what we have now, we have the x all by itself. And we said, as soon as the x is by itself, we're finished. So in this particular problem, the value of this variable x is 6. Okay? Using the steps. It's okay with everybody? That's your very first one. Any questions on this one?
No.
Okay. No questions, or you're not okay?
No, I'm fine.
Okay. Okay, let's do another one. I want to make sure that you see some different stuff. I marked some on your worksheets, so I'm going to refer back to that. Okay, let's look at this one. 6 equals n minus 4. Now, there's two things about this that I didn't explain on the last one. First of all, a variable can be any letter. It doesn't have to be an X. It can be any letter. Don't let that throw you at all. And the other thing that looks different here is that the n is on the other side, which doesn't matter either. The whole idea, draw a line down through the equal sign, circle your variable so that we see what we want to have by itself. If I want the n by itself, that means I'm going to have to get rid of this. And it's a minus 4, so how am I going to get rid of a minus 4?
Positive 4.
Add 4. I need to do the opposite. Now that's our banana. So it's out of balance right now. I have to do the very same thing over here and draw a line because we're going to see what our new equation is. We're going to add straight down. We see that a minus 4 and a plus 4 is going to zero out. You don't have to bring the 0 down. And we bring our n down. 6 plus 4 is 10. If the n is by itself, it doesn't matter which side it's on, then we're finished, as long as the n is on a side by itself. Okay?
I'm confused.
All right.
If this is a minus question, but how did you get the plus in there again on the 6 plus 4?
Oh, because what I decided to put here decides what's going to go here. I decide what makes a 0, and then I copy this over to the other side because it has to be the same banana.
Okay, so the two bottoms have to stay the same.
Absolutely.
Okay.
That's the only way we can stay balanced.
Okay.
Good questions. Good questions. Okay, y'all on remote, speak up.
I'm all right. I understand.
I understand also.
I heard some talking. You have to be louder.
I'm okay.
Okay. Just speak up if you have any questions.
Okay.
Luannie is coming in, and I want to say hi to that girl.
Hi.
Luannie,
Yes, ma'am.
hi.
How are you?
Oh, I want to know, how are you? You have
I'm
been,
good.
you've
I've
been
been
through
swamp-
it, huh?
Yes, ma'am. Yes, ma'am, but I'm better.
And you don't live in Lubbock anymore, right?
No, ma'am. I live in what's this place? I can't Lorenzo. I'm so
Lorenzo?
funny. Yeah, I said I'm gonna see if I can get on because I actually don't go back to work till next week.
Oh, I'm so glad. Well, today what we're doing is learning to solve equations.
Oh, good.
I think you're pretty good at this one. It'll be a good review.
Yes, ma'am.
Okay. And we just started, okay?
Okay.
All right, let's do another example because solving equations uses the same steps over and over again. But it won't be clear until you've practiced and practiced and practiced and practiced. Okay, let's do this one, and you guys are going to tell me what to do. Okay, first step, very first step, what do you do before that?
Draw a line.
Draw your line.
Yes, yes, yes. And then, okay, we're going to draw a line down so we can see the two sides of the equation. And Rachel said, then we circle the A because that's what we want to have by itself by the time we're done. Okay, now the reason I picked this one is because we need to be careful what signs go with what numbers, okay? This looks like the positive goes with this 4. But the sign that is on the left goes with whatever's on the right, okay? So since this 4 doesn't have anything out in front, it's an assumed plus, okay? So the sign for the numbers go to the left. This plus goes with that 4. This plus goes with that A. Okay? The sign is always to the left, so don't let this confuse you. The back side doesn't go with that number. It's just coincidence in this case. Okay? All right. And then what we do, we're getting ready to start. And so we want the A to be by itself, so we focus on this side because this is the A side. And we say the A isn't by itself yet because there's a positive 4 here. We need to get rid of the positive 4. How are we going to get rid of the positive 4?
-4.
And a minus 4 because it's plus 4. So we're going to minus 4. And that's our banana. We have to copy it exactly to the other side. That makes everything balance back out again. When you get to that point, now we're going to add everything straight down. We've got a positive 4 and a negative 4. We know that those are additive inverses and that equals 0. So when I add straight down, all I have is an A. And the equals goes on the line to keep all of our steps straight. And now we have 13 minus 4, or you can say 13 plus a negative 4. It'll give you the same answer. And so we have 9. Okay? Now we look at what we have, because later on you'll have to go some more. But you look at what you ended up with, and if the A is by itself, we're finished. If the variable's by itself, we're finished. And the value of A in this particular problem is going to be 9. Good? Let me see if there's more. I circled several that might give you okay, here's one. If y'all need help, be sure and speak up before I erase. No, we're good. Questions? Okay. So now, this is on your page 2 of the handout, and it's number 3 if you're keeping track. It looks scarier, but we've already dealt with negatives and positives. So this will help you go back and review your negatives and positives. The first step we do, it's always going to be your first and second step. Always. Here's first step, second step. Okay? First step, second step. So that means that we're going to focus on this side because that's where the P is. So I'm going to focus on this side. P is not by itself. Here's a minus negative 8. What did we find out when there's a negative right next to another negative? Okay, we can turn it into a positive. If we've got 2 negatives right next to each other, nothing in between, or no numbers in between. So now this is a plus 8. Okay, now that we've taken care of that, how do we get rid of that plus 8? Subtract 8. Subtract 8, and it's out of balance, so I have to do exactly the same thing to the other side. Now we know that the positive 8 and a negative 8 added together, they're called additive inverses, and they create a 0. So when I add straight down, all I have left is a P on this side. Brought it down. The equals always goes on the line to keep your steps straight. Now I have a negative 4 plus a negative 8. Or however you think about it, negative 4 minus 8. But we decided when we were working on negatives, and this is going to help you, if I have some negatives and I add some more negatives to it, then I've got a whole pile of negatives, right?
Yeah.
No,
It-
no.
Oh, it's one. It's like, it goes-
I've got 4
yeah.
negatives. There's 4 negatives.
Oh,
1, 2, 3, 4, 5, 6, 7, 8. Those are negative 2. Okay? I've got 4 negatives, which are the dark discs.
Yeah.
Okay, and I'll explain. Did we do that in class? Okay. These are negatives are dark
Yeah.
and positives are light. And a negative and a positive mark each other out. Okay, well, in this case, I have 4 darks and I have 8 more darks because they're both negatives.
But you can't.
I can't cancel anything out because there's no positives to cancel. So I just put all these together. And so I've got 12 of those, if you count them. I've got 12 of them, and they're the dark ones, so they're negatives. Okay, and I'll explain that more, Brandy. Okay, Rachel's already seen that. So we have P equals negative 12, because if we look, the P is by itself. We're good?
I was almost getting it. I was trying to figure it out.
You were.
How to do.
Mhm. If the signs are the same, we just add them and use that sign. Okay. Any questions on this one? This will review your negatives.
I was remembering that it's negative and negative on both. It runs as you add them both.
That's if it's multiply or divide. Different rules. Okay. Okay. Any questions here? Okay. Your best questions will come when you start to practice, and that's the way it should be. Let me see if I did any other problems. Yeah, there's another one on this page. Let's do this one. It deals with negatives again. Negative 5 equals u minus 7. Now, if you'll continue to use the very same steps over and over and over and over and over and over again, I still use this. Okay? Put the line down through the equal sign and go look for your variable. Your variable is right here. Okay? So that means we're going to ignore this side for a minute. We're going to talk about this side because that's where the variable is, right? The variable is not by itself. This is what we have to get rid of. It's a minus 7 because the sign to the left goes with the number, okay? So it's a minus 7. How do you get rid of a minus 7? Opposite of minus. Oh, so we're going to add 7. That's how we get rid of that one. And if I do it here, it has to be done here. Okay, and very first we see the 7s are the same. They have opposite signs, so that makes 0. And we bring down or add everything down. We have a U, equals goes on the line. Now we have a negative plus a positive. We found out from our rules, there are 2 ways you can look at this. You can say if the signs are different, you subtract to give the sign of the largest number, okay? So the signs are different. If we subtract, it's 2, right? Give the sign of the largest looking number, which is 7. So it's going to be a positive 2. Do you see? Or the other way is to use our discs, and I will show you that again. The dark dots are negatives. So I need 5 dark dots. 1, 2, 3, 4, 5. Positive dots are open. 1, 2, 3, 4, 5, 6, 7. Now we found out that if I have a dark dot and a positive, a light dot, this is a negative with a positive. It's just like here, a negative with a positive is going to make 0. So we can cancel out this and this because that makes 0. Here's another dark with another light, another dark with another light, dark with a light, and dark with a light. So all of those are gone. What's left? 2, and are they positive or negative?
Positive.
They're positive. That's how we got positive 2. So either the dot method or the rule method, I don't care, whichever one you use. And of course, on the GED test, if this isn't one of the first 5 questions, then you can also use your calculator, okay? But it's good to have the rules in your head, okay? And know how to work this. So when we look at this problem, you have to examine it one more time before you stop. And you say, is the variable by itself? Yes, it is. Because later on, probably tomorrow, later on, we're going to get to this place and it's still not finished. And then you'll have to do something else before you can get your variable by itself. Okay? Any questions here, y'all? We doing okay?
Yep.
Yes.
Okay, Jesus, you still awake?
Yep.
Okay. I just can't see your pretty face.
Seems
All
like
right, let me look here. Okay, it's time to move to the next one. Now, the page 3, I really think we need to wait on that until it's going to be after page 5. So if you numbered your pages, then you need to do page 4. And it's this one. I'm skipping a page if you have them in line. It says multiply and divide, level 1, S1. Level 1, S1. And I'll get that. I'll be right back. Here's, did you get this? Yeah. Okay, I'm kind of waiting for one of our students to come back. So I will write this question. This is number 6 on page 4. Page 3, I kind of had that out of order. I want you to do that later, close to the end, okay?
Page 3, is like last.
Next to the last, yeah. Okay, we'll go ahead and do this one and we'll do another one here in just a minute. Okay, now this time you notice that there's no pluses or minuses in this. But remember that if 2 things are crammed together, that's an understood times. They don't always write it, but it's times. Okay, so we drew the line down through the equal sign and we circled the variable. And we know that we want the C to be by itself. So I have to get rid of the 6. Now, what we're going to look at, I'm going to start this again. This is, I turned your pages for you,
Okay.
and we're on number 6.
Okay.
Okay, now we're going to start something different here. And we put our line down through the equal sign and we circled our variable, okay? But this time we notice there's no positives or negatives in here, or plus or minuses, I'm sorry. But when 2 things are crammed together in mathematics, there's an understood times here, an understood times. So the 6 is multiplied by the C. Well, remember at the beginning of this lesson, I said addition and subtraction are opposites. What's the opposite of multiply?
Division.
Division.
Division. So the way we get rid of a multiply is we have to divide. Now, a lot of people would want to put divide here, which is fine, but it's confusing. So what we do is use the fraction sign to indicate divide. Remember that this fraction sign means divide. So if the C is multiplied to a 6, in order to get rid of the 6, I have to divide by 6. Okay? Now, this is the banana. So we're out of balance right now. We have to do exactly the same thing over here. So I'm going to have to divide by 6. That divides our steps, or separates our steps. Now, if we look over here, 6 divided by 6, a number over itself is always equal to 1. And 1C is the same as just a C. The 1 is invisible. Okay, so we have 1C equals goes on the line. And this says to take 24 divided by 6. 24 divided by 6 is 4. Okay? Now we look at our final answer here. Is the C by itself? Is our variable by itself? Then we know we're finished. We're finished. And the value of this variable C in this problem is 4. Okay? So multiply and divide are different than add and subtract. Questions on this one? Remote people?
No, ma'am.
We're okay?
Okay.
Yes, ma'am.
Okay. Let's do another one. Okay, now let's look at number 4 on that same page. Says 14 equals A over 2. Okay, uh-oh, now what do we do? Oh my gosh. Let's put a line down through the equal sign because those steps never change. And we're going to circle our variables so we know where to focus. We're going to focus on this side.
Since it's divided by 2, wouldn't you divide it by 2 on the other side?
No, it divided by 2, you're correct. But we have to ask ourselves, how do I get rid of a divided by 2?
Times.
I have to multiply by 2 because I have to do the opposite operation.
Yes.
It is divided by 2 right now. I want this gone. So I'm going to multiply by 2. If I multiply this side by 2, I have to do this side by 2. The reason I put this high is when you multiply fractions, I like to have a fraction and a fraction. The 2's cancel out and I have A over 1, which is A. Okay, if you go back to your multiplying fractions, you might want to go back and review that. We had a section on multiplying fractions. But this 2 over 1 is exactly the same as the 2. They're the same. 2 and 2. Okay?
Yeah, you get the wrong number.
So on this side, we finished with this side and have an A because those all canceled out. And then we have 14 times 2 is 28. A is by itself. So we're finished. The value of A in this problem is 28. Now tell me, would you have been able to look at that one and just say, oh, answer's 28? No, that's why we have steps. That's why we have steps. Question on that, Brandy? That looked like you had a question.
No.
You're just thinking, believe it or not, there's nothing new today. We're just going to go over some more of these, then let you practice, okay? Okay. Tomorrow, we will put the add and subtracts with the multiply and divides, but it's just separate steps, okay? But today we'll keep them separate. Let me look through the rest of the problems and see if there's any. I don't want to just leave you hanging. Let's do this one. Q over 11 equals 1. Okay. First two steps.
Line down the equal sign, circle
The variable. Okay. When we circle the variable, it says, look at this side. Okay. And then it says, what's the extra stuff? It's a
Divided.
by 11, right? It's divided by 11. How do I get rid of a divide by 11? Good. I'm going to multiply by 11. And I'm going to multiply by 11. Since that's a fraction, I just put it over 1. The 11s cancel. So that just leaves a Q on this side.
And then that'd be 11.
And 1 times 11 is 11. So the value of Q is 11. Getting better? I didn't see all of the yeses yet. Let's try some negatives here. Okay, I'm on the next page, which would, if you numbered your pages, would be number 5, page 5. And it's going to be number 2. For y'all here in the classroom, it's just the next page, number 2. Negatives. You guys see why I made you learn about negatives and positives before we did this?
It all makes sense now.
Line down through the equal sign. Circle the variable. Okay, now. I think we can do this one of 2 ways. I think I'm going to do it the most obvious way for y'all. Okay?
Is it because you want 3 times 4?
Pardon?
4, you have 3 times 4. But no, it's to get rid of the 12. I mean, to get rid of the 3.
I need to get rid of the 3. Okay. What operation is it? It's
Negative.
It's
Positive.
divided by 3, right? Don't worry about the negative. It's divided by 3. So how do I get rid of a divided by 3? Multiply by 3, correct? Nothing new. All right. So obviously, the 3 and the 3 cancel because that's what we want to happen. So all that's left is a negative A. A negative A. Don't ignore that negative. And then a negative times a positive gives us a negative answer. Now, you need to be careful at this point because it looks like the A is by itself, but it's not. It has a negative out there, and we can't have a negative A.
No. So
Okay.
you have to add a positive A.
Then it would be,
No.
then the A would be
No.
gone. This is something I haven't told you. And understood in front of the A, there's always a number, always in front of the variable. If there's not a 5 or a 2 or a 6 or whatever, then it is an understood invisible 1. And you're going to find out that this invisible 1 hangs out a lot of different places. I'll call your attention to them when it happens. But the invisible 1 is just like floating around. It goes everywhere. So now I have a negative 1a. If I circle the a, that means I still have to get rid of the negative 1, right? Be very careful. This isn't a minus 1. It's a negative 1 times. See how it's crammed up next to it? The times is what's important. So how do you undo a times?
You divide.
By the same thing. If I want to get rid of the negative 1, I'm going to divide by a negative 1. Yeah. No, I'm looking at you.
Oh.
If I divide by negative 1 here, I have to divide by negative 1 here. Remember, I have to keep the same thing on both sides. So we found out in our rules for negatives, go back and study. Negative divided by a negative now is positive in multiply and divide. So now I have 1 divided by 1, that cancels out. The 2 negatives cancel out, and all I have left on this side is a positive a. The negative divided by a negative is a positive.
That's right.
Yes, you did. And 36 over 1, or 36 divided by 1,
It's
is
36.
36. Yes? Couple of new things there, just to remember that the negative, we can't leave a negative. We're not finished if there's a negative. We have to divide by negative 1. And what was the other thing? I think that might have been it. Okay. Questions?
No.
I don't want to cram anything else in right now. I want you to practice these. But I did promise that if you had questions on distributive property or order of operations from yesterday, I will do any of those problems before we get off of the recording. Questions that you marked yesterday on order of operations or distributive property?
I have
I got a
some.
question.
Okay, I'm hearing a couple of them. It was Sherry and was it?
Jesus. It's me and Jesus. He had a question also.
Okay. Okay, Sherry,
No.
you want to give me your first one? You'll have to give it to me. I don't have the page out.
Well, yes.
Is it that one you sent me?
No. It's pack 1, page 7, number 7. I can
Hang on.
tell you the problem.
Let me get there. Tell me again. Is it on the order of operations or distributed property?
Order operations.
Okay, and tell me the page again.
Page 1. No, pack 1, page 7.
Okay. What number?
Number 7.
7. Is it the 0.45?
No. Maybe I got my paper's number wrong. It's
Right.
okay. You want me to just tell it to you?
Yes.
It's
You'll have to speak loud because I have a
okay.
fan on.
Okay, it's 4 plus 2 over 3, subtract 3 plus 1 over 2. And I'll go ahead and tell you some of the reason that I've having some problems with some of them. It's because, when we were doing fractions and I said, well, I'm not sure what to do with this whole number is hanging out here and I don't have nothing else to group it with. I forgot how you told me to do it.
Okay.
And so I'm struggling with that.
Okay. Probably, let's see. I'm trying to think of the best way to show you. And then those of you that want to try a faster, cooler way, I'll show it to you. You don't have to know it. Okay? But for right now, we're going to do the please excuse my dear Aunt Sally, right? Okay, no parentheses, no exponents, and I don't see any multiply and divide. So add and subtract, we're going to do those first. If you're not using your calculator, then we need to be able to do this. Okay, and what we're going to do is write it up and down. 4/1 plus 2/3. And we get common denominators, which will be 3, right? Looking at, am I going too fast?
No.
Okay, and then from 1 to get to 3, I had to multiply by 3. So multiply by 3, and I get 12. This is if you're not using a calculator. And so when I add these, they have common denominators. I'm going to get 14/3. Do you see that so far, Sherry?
Yes.
Yes?
Yes.
Okay.
I think
Oh.
what I messed up was that 4, I was thinking he was a whole number. You know what I'm saying?
But you put it over 1.
Well, I didn't. That's where I messed up at.
And then you put the rest of the problem around. It says add and subtract left to right, so we have to do this one next. So I have 14/3 minus 3/1. Common denominators again are 3. This is 14. This is 9. Because I had to multiply by 3. Now this is subtract. So I have 14 minus 9 becomes 5/3. I have 5/3 plus 1/2. And one more time, I have to have common denominators. So I have 5/3 plus 1/2. If I look at the denominators, my common denominator is going to be 6. 6. If y'all can't remember this, be sure and go back to our fractions section. If you need some work on that, be sure and let me know. 2 times 3 is 6, so I have to take times 3. 3 times 2 is 6. Now I have common denominators, which are 6, and I'm adding. So I get 13/6. Yes, Sherry?
I'm still.
Was that the answer?
Let's see. Well, actually, no. They're
No?
saying the answer is 2 1/6.
Oh,
and
okay.
I worked it like 3 or 4 times, and I'm like, and I even did. I just could never get it.
This is the right answer. 13/6. What they did is simply change it to a mixed fraction. Remember that this is divide. So I'm taking 13 divided by 6.
Okay, going to
6 will
13
go in here 2
twice.
times. 1/6 left over. So all they did, from what we did, they changed it to a mixed fraction.
Okay. Well, those ones that look like whole numbers, See, that's what was messing me up was that 4, because I'm like, well, and there was several different ones that was the same way. They look like whole numbers, and then when I looked at it, I'm like, well,
Okay,
that's a whole.
I'm gonna show you guys something. Because we will be able to use this later. You do not have to know how to do this right now, but some of you will be excited about this. Okay? So let's do this problem again. And we're going to do it where the very first step I'm going to do is get rid of all the fractions because they're a pain in my butt, right?
Yes.
So I'm going to do 4/1 plus 2/3. Do you see I'm just making this a fraction? Minus 3/1 plus 1/2. Okay? Any problems with that? Okay. So now the quick way to do this is to get rid of all of our fractions at one time. We can do this all at once. What we do is look at all of the denominators. What would be the common denominator?
It would be 3. I mean,
3 won't go in there.
I'll give you the ones.
1,
Six.
6.
Would
6.
be 6.
Okay. 6 is the common denominator. Now that's our key.
Okay.
We're going to take the entire problem and take everything times 6. We're going to use the distributive property and take everything times 6. Sorry. Forget it. We can't do that unless it's an equation. Sorry. Okay, you're going to have to do it the old way.
Well, I was thinking.
My bad.
When I was doing
I don't know, but I got 2 and 1 6.
but I went
Mm.
Miss
2.
Deborah,
Oh, I can't remember the problem.
it was 4 plus 2/3. Take away 3 plus 1/2.
Okay, and you're saying you did these first,
Yes.
which would have been a +4 and a -3, right?
Yeah.
Okay, that would be 1. And then you took care of those, okay? And then,
And then I did the, yeah, okay, so then I added from like 4 and plus the 3, and then add 2 on top. And then that made it a 9. Okay.
can't do that. Mm-mm. Sorry,
It's okay.
you're really
Yeah,
thinking well, but no, you can't do that,
Okay.
okay?
Miss
Did
Deborah,
that? Yes,
the way I did it, I put all of them together in the calculator and it came out to 13/6. And then I
Yes.
divided it into 6 divided into 13. And I came out with 2 and 1 6.
yes, that's exactly right. So what she's telling us that if that type of problem right there that we just did is not one of the first 5 on the GED test, you can just use your calculator. Okay? Yes, that's good, Isabel.
Okay.
Jesus, did you have one?
No, I was just asking if y'all could review some of those.
So you're okay?
Yeah.
Okay. Any other questions from yesterday?
Well, the
Miss
one
Deborah?
I'm having problems is with the one with the L1MS1. And it's problem 5.
Okay. Tell me again which page it is.
L1MS1.
Okay, and number 5, if I'm looking at the right place, it's 1 plus 3 times 2.
No, it's 6 and it's got 3 on the top, square 3. plus 2 times 3.
I'm almost there, I think.
It's toward
If
the
not-
last pages.
And you said it's problem number 3, right?
Number 5.
Oh, 5.
Yes.
Okay, tell me the problem again.
It says 6, 3 plus 2 times 3. Square
6,
3. I mean.
3.
L1, L1, M, S1.
Okay. L1. MS1. Oh, okay.
Page 11, I think.
I see it. Let's do that one. 6 cubed plus 2 times 3. This one, right, Irene?
Yes, ma'am.
Okay. This is probably what's bothering you. And the exponent means, well, yeah, an exponent means take the base times itself this many times. So what this right here means is 6 times 6 times 6. That's what it means. Now in your calculator, if you're going to do this, you can just put in, you can push the 6, and then there's a button on the left-hand side called a caret top. That's to the power of 3, and that will find the answer for you.
Okay.
So now let's do the whole problem. So again, it's order of operations. Please excuse my dear Aunt Sally, okay? So there are no parentheses. And this says do exponents next. Now that's what this is. This is called an exponent. And so we're going to do only this piece. And when we find 6 times 6 times 6, I'm pretty sure, is it 216?
Yes.
6 times 6, 36. Yeah, 216. Did you get that, Isabel?
Yes.
Okay. Write the rest of the problem around it. Then we look to see if there's any more exponents, and there's not. Then we look at multiply and divide, whichever comes first. So I start left to right. There's an add. There's a multiply. So I have to do this first by the law of the order of operations. So 2 times 3 is 6. And I have to add or write the rest of the problem around it. I only have one more part to do. So it should be 222.
Yes, that's what I got.
This may be where you had a problem. You tried to do this first?
Yes.
Yes. You need to follow this carefully, and you do multiply and divide before you do add and subtract.
Oh, okay.
Okay? That's a common place where people get mixed up. Any others?
No, that was the only one.
Lou Annie, how you doing?
I'm good.
Okay, are you getting these worksheets that I send
Yes,
out?
ma'am, I have it. Yes, ma'am.
Good, good. You be sure and let me know whatever you need.
Yes, ma'am.
Jesus, Brittany, Sherry,
Yes.
y'all doing okay?
I'm
Yeah,
good,
good,
thank
good.
you.
Okay, what I want you to do today is practice the one-step equations with the add and subtract and the multiply and divide. Tomorrow, we're going to take both of those things that we learned. We're not going to learn anything new. We're simply going to put both of those types of equations together and solve them all in one problem. Nothing new. We're going to use what you're learning
Okay,
today.
hold on. I'm in class still.
I heard
Yeah,
somebody
yeah.
say, hold on.
No, I'm talking to my sister. She's out of the doctor,
Oh, okay. Okay.
but I'll be there in a minute.
Okay.
Okay.
Any other questions?
Okay, bye. No, not right now.
Okay. Well,
The
then
only
I
thing
will.
that I need, Miss Deborah, check my email and I don't have any of the worksheets that you sent.
Okay, did you check clear back before Christmas?
Yes, I checked everything. I went through all of them and I cannot find it.
I will send them again.
Okay,
Thank
All
you.
right. Uh-huh.
thank
You know
you.
I love you guys.
Thank you.
Okay.
Bye. Nice seeing you again.
Nice seeing you, Luannie. Don't be a stranger.
Yes, ma'am. I'll see you in the morning too.
That's great.